when this disappears.
Okay.
So if you like, hey, we got to stop, we got to get the plunge or the filler out, then you have to pump the system up. It's kind of a messy job, but
and that can be due to just very slow leaks over time. Doesn't necessarily mean something's wrong unless it's going down fast.
Exactly, and that's the best way to look at it. If it's going down slowly, and say you just have a little weepage around here, you know, even though there's oil on this, it doesn't mean anything's wrong. The plunger's still good. So exactly that. Over time, it might do that. Maybe there was a bubble in there that finally worked its way out. That's the other thing. So as long as I'm applying a small constant pressure to this bladder, I'm going to force oil out before I allow water in. The conductors, the electrical conductors, can work in oil. It's a dielectric, meaning that nothing will get shorted across each other. Whereas if water got in, you would have a ground fault because you would short out between pins. So that's why that works that way. So we've got the tether coming down into the PBOF, P-B-O-F, splitting out where we have fiber coming through this oil-filled line, and we have copper, which is power, going through this heavy-duty line. And if we trace these out, the copper, the fiber, goes to the vehicle junction box. So what does that make you think? Fiber carries what?
Light optics.
All right, and why do we use it? What does it do for us?
Faster.
Is it's faster, but do we use it to power things, or do we use it to talk to things?
Communication.
Communication. So we're saying we want all the communications to go into this vehicle junction box. And if I look at if you look at these labels, you can see what's on there. You've got your lights, your camera, you've got tilt, navigate, you've got all the functions of the ROV. So what that tells me is that this is how we communicate with all these devices on the ROV. So fiber is always going to communicate. Fiber does not carry electricity, never will. And they separate them when they get to this point. Now the copper, pretty beefy line, you can see that what happened is they probably took a lot of smaller lines, smaller, like 20 gauge, which the higher the gauge, the thinner the wire. The smaller the gauge, the thicker the wire. So if you're running a 250-foot power line out to a plug in your yard and you only use 14 gauge, you're more than likely going to break, you're going to have a circuit breaker go off because you cannot carry that much amperage that far on that thin of a wire. You'd want more like 10 gauge. So same thing here. We want flexibility, so we use thinner gauge, higher number gauge wire. And then in here, because this doesn't have to rotate, it's pretty much fixed, we can go back to real beefy lines. And if I trace that down, this is coming down through the tether, and it's going into this thing right here. And if you read that, it says 500 volts DC. So this is the vehicle power supply. So that's where all the 500 volts DC is taken. And then from that, the power, which is right here, comes back up and then energizes all the devices, because not everyone uses the same amount of voltage. Some things use 24, some things use 48, some things use 12, some things use 5. So it's the whole idea of distributing the power correctly to the devices. So that's what this is, essentially a giant transformer and voltage regulator that then powers everything else. So does that make sense? Pretty straight, and all ROVs are going to do something similar. Sometimes communication, like on that ROV over there, it's done with copper. They don't need a whole lot of extra communication capacity. It doesn't have the same complexities that this one does. So tether, fiber breakout bottle, which is called a pressure balanced oil filled connector, PBOF. From the PBOF, communication goes to the vehicle junction box. Power goes to the vehicle power supply, which then connects to the vehicle junction box. So just think of it from a block diagram system perspective. Okay, so now suppose I'm going to do something with this vehicle. I got a problem. I got to put on a new sensor, something that is not standard. So what I'm going to do is I'm going to take all these hand tight
is there a reason they're different shapes? Just kind of where they fit?
well, this allows you to cinch down on this, and I'll show you
and
why.
that goes on top, so there's 2 for one.
Yeah, exactly.
Got it, okay.
Two things for each one.
So is the box almost working like a, the little box working like a washer kind of?
Well, I'll show you when we'll open it up. Yep.
Okay.
So I'll give you an idea here why it's done like this.
Okay.
So, you know, do things like, so this is atmospheric pressure. So this is a 1 atmosphere bottle. What does that mean? What do you think? If someone says it's a 1 atmosphere pressure housing.
It's like our atmosphere?
Yeah. So basically, the pressure in here is the same as we are right now, more or less. If I go deeper into the water, what happens to pressure?
Goes up.
Goes way up, right? But inside of here, we still have 1 atmosphere. So this cover is being pressed down into it. We don't want that to leak. We don't want water getting in. So in this case, how do we keep water from coming in?
Rubber seal?
What's that? An O-ring. Yep. Some sort of seal, and in this case, it's an O-ring. And so I've taken all those things off, and I'm just going to move this. So on this side of the ROV, there's a pressure relief. This thing allows us to pressure test that seal. But first, I'm going to take it off, because if I try to open this with this on, it creates a vacuum and it won't let me open it. We never lose this. This ROV never goes in the water with this on, without this on, secure. This vehicle, if I'm on board, I never not put my hand under there and give it a quick tight. Whether I'm doing it, John's doing it, you're doing it. If I'm on board, I do that, because that will blow the entire system up and it will cost $80,000. And there is no other option. It's ruined. So I always check that, and that's a very important thing for everybody to have on their procedure list. So now I've got to change something out. So I'm going to grab onto this little, it's like a handle, and I'm going to pull up. I'm going to show you. So that's what it looks like inside. Looks complex, right? But if you look inside here, you know, we see it. There's maybe a couple small drips. It could have been from water on top when we opened this. A little bit of sand, but there's your pressure port. Now in here, this is where all the magic happens with how stuff connects and so on. And so if you look at this, yeah, it looks really complex, but what do you think these are? They're fuses. I mean, and you know, they're basic fuses. Everything has its own fuse. So the thrusters have a certain amp fuse. The lights have a certain amp fuse. Some are the same, some are different. You fuse something, why?
Just to prevent it from overloading.
Yep. And so some things require more amperage, so therefore the fuse would be a higher load. Others are smaller, and you don't want to over-energize them, so it'll have a lower fuse, like a 2 amp or a 1 amp fuse versus a 7 amp fuse. Okay, so when the vehicle is energized, sometimes you have to do work in here. You don't touch any of this stuff, because there's a lot of voltage and a lot of amperage in here. So you have to be careful. What is this? What does this look like to somebody? Have you ever seen this before, this type of wire?
It's like Ethernet, kind of.
Yeah, it's Ethernet, exactly. And so if we look at the Ethernet, where is it going to? It's going into a device called the balefire, which is, why would we want an Ethernet connector for a device? What does that tell us about the device?
Data transfer?
Yeah, data transfer, but what about it?
Communication purpose.
What's that?
Computer, the communication between the Falcon and the computer.
But is it, how about in terms of volume or speed?
Needs to be quick.
Quick and probably data heavy. So Ethernet allows us to transfer data at a high rate and at a high capacity. So if we go right next to, you know, if we trace this down, if we followed where the red line comes in, you can see it goes in right here. And so I'm following it right here. It plugs into this board, and we see from out of that board is this yellow line right here. What do you think that is? So it's hard to see. I know it's hard for you, Mercedes, but if you come over on this side, you'll see better. This is a fiber line. this fiber line is coming right out of, if I trace the yellow line, I can see it goes right into the fiber oil field. So you can see this, the oil doesn't go all the way through, it stops right here. But this is fiber. Fiber transmits communication. Therefore, the fiber plugs into this card, which then communication comes out of. So we call the card a multiplexer. Have you heard that term before, multiplexer? So a multiplexer is a device that takes communications and transforms them into the, whether it's an analog or a digital signal that then controls these devices. So sometimes it's Ethernet, sometimes it's serial, sometimes it's RS-232, sometimes it's RS-485. It just depends on what the device is. And so the whole point of this is that the MUX card is where the fiber terminates, and then the MUX card distributes the information, communication to the various devices. It also accepts the information back. So like the sonar is providing us feedback. So that sonar communication comes back up into the MUX card and transfers up the tether through the fiber. So this MUX handles all the communication. So MUX, or multiplexer, is what that stands for. Now, if I have a multiplexer on the vehicle, I have to have one at the surface too. So the identical card, and I'll show you inside, it's a lot easier to see, exists up there. And so communication coming from the vehicle goes through the MUX and then gets converted to go up the fiber, and then it goes to that MUX card and gets communicated back to a computer screen, to a heads-up display, something that gives you information about what's going on. So multiplexers give you a lot of flexibility with sensors and communication protocol, a lot more adaptability to the vehicle.
And they always come in pairs no matter what?
You always have to have a surface and a vehicle side. Yep.
Okay.
Yep. And so this is another point of failure potentially for fiber that you can have. Now, you see there's two fibers in here. So this tether has two fibers. We only use one, so one's a spare. So what happens if we break something in there, we can go to the spare fiber and not have to diagnose the whole tether, which is kind of nice. Fiber, again, will usually fail near one of the ends, and you can splice fiber, and you'll learn that if you're taking EET 304. John's certified in it. He had to take a class in that. It's a nice skill for anything you're doing in communications, regardless of whether it's an ROV. So everything else on here plugs into an interconnect. So if I have a problem, say a thruster isn't working, and I can't figure out what it is, I'm eventually gonna open this up and troubleshoot. And one of the first things I'm gonna do is I'm gonna look at all these indicator lights on these fuses and make sure no fuse burn out. So if I see a red light instead of a green light, and I'll show you this once it's powered up, then I would say, oh, there must be a fuse that's needs to be replaced. If that looks good, then I know my fuses look good. So next thing I could also do, without even powering up, is I could check all these connectors. So see how they can pull right out? So sometimes they might get loose. Looks like it's okay, but it's not in all the way. Or someone might have messed with it and put it in one pin off, right? And that can happen. So by feeling this and looking at them, you could determine that. We've had this happen numerous times. A lot of times they'll put a little dab of Loctite or some sort of real residual adhesive that doesn't cement it there, but just keeps it from wiggling out. Think about it. We were in the trailer. This vehicle was bouncing around coming down here. These things could have easily popped out. So I'm going to check them all anyways. And I know it worked yesterday.
Is that a check you would do every time you move it so far? Because I know there's different checklists for, like, if you move it a certain distance.
Well, first thing I would do before I open this up is turn the vehicle on and if it all works that way, then the less you have to open it, the better.
Okay.
So you can see here's your O-ring. You see this little O-ring in here? I'm not going to pull it out right now, but there's an O-ring and a groove right here. That's what seals this from water coming in. And so there should be a light grease on there, which there is. There should be no grit on there. So everything looks good. So I'm gonna put this back in sort of carefully. And then I'm gonna push it down. Okay. And then once it's down, I'm going to grab another test before I even put those things on that I took off earlier. I'm going to grab the vacuum tester. And so now, remember that plug I took off? If I tried to push this back on with that plug off, I wouldn't be able to because the air wouldn't purge. So it'd be like creating a little pressure bubble in there. So I've left that off so the air was pushed out as I closed off the lid. Now I'm going to put this on. This is to do a vacuum check. This is a check you'll do every time the vehicle goes into the water. And you screw this on.
But that's something we don't do on the Outland because...
Yeah, it doesn't have one.
Got it. So you just gotta hope?
No, the Outland doesn't have the same type of complexity, so you don't have to do that.
Got it, okay.
It's just a little pain to get on here, but...
Keep throwing it back in and we all have to
okay. So I screw that on, and now I haven't put these on, so it shouldn't matter because a seal's a seal regardless of whether I'm pressing it on. You think about it, once this vehicle goes say below 30 feet, we're already exceeding an atmosphere of pressure pushing on this, so the seal should stay regardless. So what I'm doing is I'm going to pump this up. And I'm going to pump it up to about 10 inches of mercury in vacuum. And there's a gauge on here, and I'll show you how to read that. What you're going to do is every time this vehicle goes in the water. And typically, it's this is your primary check for safety. Other things could have failure, but more than likely, they're not going to be catastrophic. This would be catastrophic. This would cost.
How long do you wait after you pump it up?
No, that's next thing is that you wait about 2 minutes.
Oh, okay.
And so I'm going to get it to 10, and the reason I stop at 10 is because I could pull a giant vacuum on this, and that will really suck that lid down. But that's not what I want to know. I want to know where it's going to fail at the easiest point. So typically seals on ROVs fail in the first 30 feet or near the surface, because that's where the pressure of pushing that seal into its proper location is the lightest. Once you get down to the bottom of the ocean, you've got so much pressure, there's no way for a seal to really fail unless there's a nick in it. So I've got this held at 10, and because I'm the one looking at it, I'm gonna watch it with one eye and then kind of put it next to one of the lines to make sure it doesn't move, and it cannot move at all. The blue ROV, which is the more of that little hobby ROV you may have heard about, the blue ROV in their manual says that it should not go down more than X inches of mercury in a minute, which I think all that's telling you is that there's a leak, but they consider that to be okay. So again, roughly 2 minutes. It's okay to go longer. If we hadn't used the vehicle in a while or done major work, we might let it go for an hour and then look at it. I mean, this is just a real fail-safe way of making sure that seal works, because there's no way for water to get in if this vacuum is being held. So again, we're not pressurizing it, we're pulling air out. So we're pulling a vacuum versus pressurizing a system.
So you're talking about atmospheres before. How does atmospheres relate to pounds of mercury?
Inches of mercury.
Inches of mercury.
Yeah, and so you could look up the conversion on Google. So you got your phone?
I do.
Yeah. So just look at it. Look at 10 inches of mercury in terms of atmospheres. I think it's just slightly below an atmosphere.
Is there a reason we use two different? Is that kind of like inches versus centimeters?
Well, this is just you typically pull a vacuum in inches of mercury. It's more of a standard. You can use kilopascals, which is another, but no one says what's the barometric pressure, and then you say so and so kilopascals. Usually say what? Millimeters of mercury.
Oh, okay.
Or millibars, or there's so many different ways. But we are pulling a vacuum of 10 inches of mercury.
So 10 inches of mercury is equal to about 1/3 of an atmosphere.
Okay, about 1/3 of an atmosphere. So it puts so this is not moved at all, and we'll do this again once we get it all ready to dive. So I'm also going to show you that how well this works. Can I see how I'm pulling up as hard as I can? I cannot lift that out because it's getting sucked in. So that just means it's working really well. And if I go back and look at this, it hasn't moved.
Have you guys ever had to replace the seal?
No, but you do check those O-rings. And then the other thing is that if I try to unscrew this with the vacuum being pulled, can't do it. It'll, or at least it's very hard. So I'll unscrew this, see if we can get it to release. Oh. So there it goes. There. So you can unscrew it, or you can push a relief valve there.
Is one better for the vehicle than the other?
No, it doesn't matter. It's just
Okay.
air. So
Okay.
yeah. So I'm going to put this on just because I don't want to lose it either. But okay. So these are all basic checks that you do for this system. So I'm going to put this back together. You can see it's real simple. I put these on, and because they don't really have to do much, you just finger tight them. They're just there to keep this pressed down. So what about if I had shipped this vehicle from California to Michigan in an airplane? What are some of the things I might want to consider?